Okay, so today we're going to talk about functions, piecewise functions in 3.4. Before we get to the piecewise functions, we just want to look at some other types of functions. You know, we've been graphing straight lines up till now. You need 2 points to draw a straight line. And now we're going to look at functions or, equations. They mean the same thing. Some of them with squares, some with cubes. We're going to have some cube roots, other types of functions that we can graph. Now, most of the time, what we want to do is we want to use a table of values for now. We'll learn other methods how to graph these in 3.5. But when you're dealing with the most basic type of function, in other words, x squared, where it's solely x squared, or the x cubed, where there's nothing added or subtracted to it, the best way to do it is to just look at tables of values where x is -2. A little typo there, should be -1, 0, 1, and 2. Simply because there are key points we need to locate for these types of graphs. You can't just plot any 2 points because the x squared is u-shaped. Okay, the x cubed also has a unique shape. So there's certain points that you have to find. But as long as we're dealing with just the basic function itself, we can use these 5 points. And if I make my table for x and y, I can again choose my 5x values that we want to plot and find the y's for. And remember, f of x and y mean the same thing. So f of -2 is -2 squared, which is 4. F of -1 is -1 squared, which is 1. F of 0 is 0 squared, which is 0. And what you'll notice about the square graph, the positives and negatives are going to be the same thing. So this is going to be 1 and this is going to be 4. So now as we have those points, we want to plot them. So on this graph here, we're pretty good. We got our units here. They're all going by 5s in all directions. So we don't need to adjust any unit. We can go -2, 4, 1, 2, 3, 4, plot that one. -1, 1 is here. 0, 0 is here. 1, 1 is there. And 2, 4 is there. So now after you get those plotted, the way we want to draw these, and you got to keep in mind, these are not the only points we can graph. This is just kind of like a line, and we always want to extend beyond the points we're plotting. So it's a U-shaped graph, which any equation with a second power, any quadratic equation will have a U-shaped. The key point here, and we'll talk about this as we move on into quadratic equations later date, but that's your vertex. That's the point that you really need to find. And if you don't know where it is, you could go all day till you found it. So, that's what we want to look at there. All right, moving on to x cubed. We're going to make the same table of values. And this time we're going to now cube our x values. And when I cube -2, I get -8. If I want to find f of -1, I cube -1, and that gives me -1. f of 0 is 0 cubed, which is 0. And again, you'll notice when I cube a 1, I'm going to get 1, but this time they're going to not be both the same sign. So this graph is going to look a little different than the other graph. The other issue here is I only have 5 units in each direction, which is fine for my x's. But my y's, I need to plot -8 and +8. So what I'm going to have to do is I'm going to have to go up by 2's on the y-axis. And that's fine. You can do that. The x can be 1 unit and the y can be a different one. So if I plot -2, -8, that's actually there because this is -2, -4, -6, -8. When I plot -1, -1, I'm just going to have to kind of just estimate and go about halfway between 0 and -2, and that's -1. 0, 0 stays there. 1, 1, again, I'm just going to have to estimate and go up about halfway. And then 2, 8 is there. And then this graph here looks like that, okay? So again, your key point is right here at the 0, 0 point. That's kind of where it goes up and then kind of goes the other direction. So, anytime you're graphing the most basic form of any function, you can always choose these 5 x values and find your y's. And, we're going to be doing a lot more graphing with these types of functions from what we call the library of functions. And when we look at the next page, these are what we call our library of functions. So we have the constant function, which is the y equals horizontal line. To the right is the square function. So anytime you have a square, it's going to be U-shaped. Now, it doesn't mean it's always going to be at 0, 0, but it's a U-shape. The cube function, which was the second one we graphed, looks like this. At any time, it's going to have this shape. Don't matter what else is added or subtracted, it will always have this shape. The square root function. Now, this is only almost like half a graph, but in theory, it cannot go anywhere left here because the square root of x must be 0 or bigger. So that's why it begins at 0, 0, and there are no negatives. We have the cube root function. Always look like that. The reciprocal function, and it's kind of scary looking, but it's okay. It just makes, we just in this case do not have a y-intercept because x cannot be 0, but we still have positive x's and negative x's. We just don't have anything that crosses the y-axis. We also don't have any x-intercepts for this particular function because there's no way to get 0 for x, okay, no matter what y is. And then the last one we want to look at is the absolute value function. Now, the basic absolute value function, doesn't matter what x is, y is always positive, okay? We will get into these more in 3.5, but I just wanted to introduce them to you because really what we want to talk about today are what we call piecewise defined functions. And these are functions, so a piecewise is one function with more than one equation involved. So oftentimes you have to choose which equation you're going to use based upon your x value. So I always like to show an example of the piecewise using a cell phone bill. Back in the day, I should change this because nobody talks anymore, but that's okay. Your C of x is your cost of your monthly cell phone bill. So whatever your bill is based upon x, the number of minutes used. So if I look at the breakdown of this piecewise function, your monthly bill is $39 if minutes used, which is x, is 400 or less. Pretty much that's what that means. The minutes used is between 0 and 400. Now, if I go over 400 minutes, I have a $39 base fee, and then what I'm paying is this 0.20 is 20 cents per minute over 400. That's why I subtract. So, to get an understanding of the piecewise function before we graph them, we want to first say, okay, I have a choice here. I'm either going to use this top equation or this bottom equation based on my value for x. For part A, my cost of 100 minutes, well, 100 falls between 0 and 400. So this is your x. You look here to see where your x falls, then you choose which equation on the left to use. So my cost of 100 is just $39. For part B, 400, well, you've got two 400s here, but this first equation strictly is less than or equal to 400. So if I have 400 minutes used, I still only pay $39. This third one, okay, now I go over my 400 minutes. So therefore, x is greater than 400. This x is greater than 400. So I've got to use the second equation, and I substitute my x in this time. So as I simplify inside my parentheses, we went 80 minutes over what we're allowed to use without getting charged our extra minutes. And when I work that out, I get 39 plus 16. So my cost of 480 minutes would be $55. Okay, so when we're looking at evaluating, and anytime we have evaluating, we are given values for x, and we're going to find our y. We choose which function to use based upon our x value. So that's evaluating. So try to learn the terminology and know what you're asked to do. Now the other, tasks we're going to have to do are graphing these piecewise functions. Now they're called piecewise because, see, these are pieces of lines. Normally our lines go in each direction, but if you notice, the cutoff point here is 1 for x. They share a cutoff point. And if you look up here, this is where the cutoff point is. X is bigger than 1. X is less than or equal to 1. So in this case, this graph here goes along with this top equation because x is 1 or bigger. The reason there is a hollow circle, it's because we don't include 1 in our calculations, but we have to start at 1 because it's kind of like your inequalities. When we graphed inequalities, we would circle on the number line or use a parenthesis, and we would go to the right. But when we're doing graphs, well, we have a y value that goes with our x. So it's going to be somewhere in one of these quadrants. Okay, so when we do not include the value, we still have to account for where it starts. We just leave the circle open. The other piece is the second equation, 1/2 x minus 1 if x is less than or equal to 1. And as you can see, when x is 1, we have a point. We go on down here. We have points all the way along for all x is less than 1. We have arrows for each piece. And we have a shaded in circle here because 1 is included in our data. Okay. We still have x-intercepts sometimes. This time we do not. We do have a y-intercept in this case. You may not always have y-intercepts, but in this case you do. negative 1. So we can still find a lot of the same stuff we found in the past. Now let's look at one of these and take it from start to finish. So, again, know the difference between evaluating and graphing. Two different methods. So if I want to find f of 0, and I'm given this piecewise function, it's one function. So I say, okay, f of 0 is my x. Where does it fall? Okay, which equation do I use? Well, 0 is between 1 and negative 1, so I use this top equation. So f of 0 is 1. Next, I want to find f of 1. So when we're strictly evaluating, it's different than graphing. When we're evaluating, we again look to which one of these two equations am I going to use? Well, here, this is greater than or equal to 1. So when my x is 1, I have to use the lower equation. So f of 1 is 1. The third one is f of negative 2. So if I look up here and I say, okay, which one can I use? Well, I know negative 2 is not bigger than 1, so I'm definitely not using this one. And you may think, oh, I have to use the other one. Well, that's not true. Because this x still does not fall between negative 1 and positive 1. So therefore, I do not have an equation to use to find this value for x. And since we are dealing with functions, we have to be able to get a y value given an x. So this one is no solution. There is no equation to use. So therefore, I cannot find any value for y for any x that's smaller than negative 1. That's kind of my cutoff point, which is how I determine the domain. So when I look at what is my domain, okay, again, your domain is your set of x values that can be evaluated for a function. I know I can look at any x greater than or equal to 1. So sometimes the best way to look at this is, I know 1, I'm good. Anything 1 to infinity, I'm good. And then I look at the other equation. Well, it goes up to 1. And I stop at negative 1, and it's also from here to here. So therefore, my domain, I combine these two together, and my domain begins at negative 1 and goes to positive infinity. Those are the only x values that I can find a y for, that I can substitute into my equation. And if you look it up here, negative 2 was no solution. Negative 2 is smaller than negative 1. It's down here. So therefore, that's my domain. I know domain's always tough. It's tough on the test. It's just tough. All right, so that's finding values, domain. Next, we want to graph. So again, I graph each piece separately. So the first one I'm going to graph is the top piece, where f of x is negative x plus 1 for these values. So since we're dealing with a piece of a line, I'm going to let the if statements up here dictate what x's to choose. And I'm going to choose negative 1 and positive 1 because it's a segment. Now, think about the graph I showed you earlier about that hollow circle. When I find this y for negative 1, it's greater than or equal to negative 1, so I'm including negative 1, but I am not including positive 1. So this point here is going to be shaded. This point here is going to be hollow. And I'm going to show you what I'm talking about. So if I find f of negative 1, this is negative minus negative 1 plus 1, which is 2. Okay. I still need to find f of 1 because I have to have a starting point. Okay. Even though this 1 is not included, but it's still going to be a starting point, and that's why we make the circle hollow, because don't forget there are numbers over on this graph between 0 and 1. Okay. So f of 0, or excuse me, f of 1 is negative 1 plus 1, which is 0. So when I plot these points, I go to negative 1, 2, shade it as I've indicated, and I go to 1, 0, which is here, and I leave it hollow, and I just connect them. So that's just a line segment, no arrows, because I strictly have a beginning and an end point. Okay, now I want to graph the second piece up here. F of x is 2x minus 1 if x is greater than or equal to 1. So I'm going to, again, let the if statement dictate which x's I choose. So I start at 1 and I go bigger. That's the problem. You've got to think of, just read it. X is greater than or equal to 1. The biggest mistake students make is they choose the wrong x's. Okay? So I'm choosing x's bigger than or equal to 1 for this table. So I'm choosing 1 and 2 because I only need 2 points to draw a line segment or a line. So f of 1 is 2 times 1 minus 1, which is 1. And from what we did earlier, we left the 1, 0 hollow here, but for this one will be shaded because it is greater than or equal to 1. So we can shade that point. F of 2 is 2 times 2 minus 1, which is 3. And it's also shaded, but we don't need to worry about that. The only ones we need to worry about specifically shading or hollow is when they're included up here, one of these beginning or ending points. Okay. All right, so I go to 1, 1, and I shade it. And the other thing that, tells us you cannot have 2 shaded points here, it wouldn't be a function, the vertical line test. So one's hollow, one's shaded, which truly means we only have x producing 1 y. And then the 0.23 is right there. And make sure you draw this correctly. Since we started at 1, we're going to where x is 2, and we draw the other piece. So that's your piecewise function. They can take on many different varieties. You just have to take each piece one at a time, and the key is to choose the correct x's. That seems to be the problem with most people. They choose wrong x's. All right. Part D, locate any intercepts. Well, we have a point down here, but it's not shaded. So this is not an intercept. So in this case, the only intercept we have is a y-intercept of 0, 1. That's the only one we have. Lastly, we want to use the graph to find the range. So if we look at our lowest y is here, starts here anyway, and they all go bigger. So even though I got 2 pieces, from y is 0 to 1, I'm covered. And then once y goes 1 to infinity, I'm covered. The only issue is it's not equal to 0. So my range would be y greater than 0 or 0 to infinity and we use parentheses because it does not include the 0. Sorry about that. So again, your y values are greater than or equal to 0 or 0 to infinity. Okay? So, this is a topic, another one of those kind of topics that gives students a lot of trouble. Hopefully, we can spend more time on it in class. I think the graphs that we looked at, getting information from graphs, the ability for us to do more in class helped us because it showed on the test. I'm pretty confident that you getting a look at it, us working more will enable us to be better at this as well. So that'll be it. 3.5 will be next time.